Welcome to my channel, viewers. Today, this is the chapter is the maximum minimum and class for the 12. Okay, and this is about the discussion maximum minimum with the help of the second order derivative. Okay, and see the point here. If a function f of x is continuous in the closed interval a to b and also derivable in the open interval a to b, and suppose in between them a point c which is lie on a and b such that f dash c is equal to 0. Actually, why f dash c is 0 we later discuss about that. And the second order, that is f dash c not equal to 0 here. Okay, then the function possesses local maximum at c when f double dash c is less than 0 and local minimum at c when f double dash c is more than 0. Okay, so this is the more point. Okay, main point of the max and minimum for the second order derivative. Okay, and for example we have to follow these rules, and this is your function f of x is equal to given that the x to the power 4 minus 8x cube plus 22x square minus 24x plus 8. Okay, so this is here the first question. So now f of x is equal to x to the power 4 8x cube 22x square 24x plus 8. First differentiate this, we get here 4x cube 24x square 44x and 24. After that, doing f double dash means second order derivative, that is 12x square and 48x 44. Actually, this is first order be 0. Why this first order be 0 here? See the drawing here. This is y axis and this is x axis. Okay, and this is a curve. Okay, actually find the maximum minimum. We have to, if we want to find this height, so see this is a tangent, this is parallel to the x-axis, same as this is the tangent, this is parallel to the x-axis, and this is the tangent, this is parallel to the x-axis, and also these all are. Okay, so that's any line parallel to the x-axis is dy by dx is equal to 0, means slope is 0. So that's why we find this. Okay, and take a point 0 here. Okay, and this is parallel, then we get easily we get the height of this, and this is your point. Okay, of x here. So now for first order, this is here equal to 0. We take a common 4, so we get here x cube 6x square 11x and 6 equal to 0. So implies that x to the power cube 6x square 11x minus 6 equal to 0. Actually, this is a degree of 3. So you apply the vanishing method to factorize this equation. Actually, this is called the trial and error method. First we put x equal to 1, then we get here 1 minus 6, that is here minus 5. Actually, this is here minus 5, and 11 minus 5, 11 minus 6 here 5. So minus 5, 5 is 0. So therefore x equal to 1 is a factor. X minus 1 is a factor. Okay, and this is the one of the solution, one of the zeros. After that we have to write here like, sorry, let me talk here. So x minus 1, x minus 1, x minus 1 and equal to 0. Now this is our x square, this is our x cube minus x square, and this is my 6x. So you have to write here 5x, need to have more 5x square. So that's we multiply by 5x Okay, then this is here 5x. Now write here 6x plus 6x and minus 6, and this is equal to 0. Now take a common here as a factor, that is x minus 1, and other we have x square minus 5x plus 6 equal to 0, implies that x equal to 1. If we factorize, or x square minus 5x plus 6 equal to 0, then 3 to the 6 here, so we get here 2 and 3. Therefore the zeros are 1, 2 and 3. Okay, when explain for the maximum minimum. Okay, sorry. Now this is f double dash, put here 1, and the solution is this 12 minus 48 plus 44. So we get here 44 and 12. This is 50 something. So if we doing subtract, then it is more than 0. Okay. Therefore, the function has minimum at x equal to 1. Again, f double dash x equal to 2, and this is here, again we put here 12 into 2, this is 4, and 48 into 2 plus 44. We get here 48, 96 and 44. That is 2 and 9 and 96. This is less than 0. Therefore, the function has maximum at x equal to 2, since f double dash 2 is less than 0. After that we have to test at the point 3. So now see what happened. This is f double dash 3. So see, 12 into 3 square, 4 into 3 plus 44. 9 to the 18. Okay. $44. This is here 2, 5, 1 minus 1, 44, more than 0. Therefore, the function as minimum at x equal to 3. Okay. Therefore, the minimum value is equal to, we have find a f of 1. Actually 1 minus just, and this is f of 1. Okay, and then we simplify this. Actually we get a minima at 2 points, that is 3 and 1. So this is for 1 we get a more than, second order we get a more than, so therefore the function has minimum at x equal to 1. If we put 1, then the value of f of 1 and also the f of 3 are same actually, okay. So, and the maximum, okay, and the maximum is equal to at what point? At 2, see the second order is less than 0, so the maximum value is here f of 2. Okay, so like that you have to find the easily minimum value and maximum value also, okay. And see we why we take a first order be 0, that is introduce a point why this is a parallel to the x-axis, so the tangent is parallel to the x-axis, so dy by dx equal to 0, so the partial is as a 0, yeah. And sometime in this chapter, in this second order theorem, with the help of second order sorry, there's a sometime the maximum value is less than the minimum value actually, okay. See, you have to source this case, and for that actually, so that the maximum value is less than the minimum value, and see at that point, so this is a curve, so see this is a curve, so see this is the maximum, for this downward trend is here minimum and upward trend is the maximum, so this is more and this is mean. But if we draw a parallel line, see here, compared to this is maximum, this is minimum, but compared to these two 2 point at this height is, at this height, see this height is more, but this is minimum, so this is maximum, so this is this minimum is more than this maximum, okay. So sometime after some curve the maximum value is less than the minimum value. For example, this we have want to do this, this is 2, and see f of x is equal to, that is where 2x plus 1 by twice x, okay. Now differentiate f dash x 2 minus 1 by 2x square actually, and this is second order, derivative of 2 is 0 here, so this is here minus half, and this is x to the power minus 2, so you get here minus 2 and x to the power minus 3, so minus minus plus, that is here 1 by x cube, okay. And we have to take a point f dash x is equal to 0, so we get here 2 minus 1 by 2x square equal to 0, so therefore the 4x square minus 1 equal to 0, so x is equal to plus minus half. When f double dash x equal to half, then we get here this is 1 by 2 cube, actually more than 0, so therefore the function has minimum at x equal to half, therefore the minimum value is equal to f of half, and see 2 into half, this is 2 into half here, so this is here 1, this is 2, okay. Now we have to test at the point x equal to minus half, so see this is here minus 8 less than 0, therefore the function has maximum at x is equal to minus half, therefore the maximum value is equal to f of minus half, and that is equal to, we put here 2 actually 2 minus half actually. This is 2 into minus half. So minus 2. So see, this is the maximum value. See, this is the maximum value. See, this is the minimum value. This is 2. Actually, this shows that the minimum value is less than the maximum value, and it is only depend on the curve, nature of the curve. So that's why it is happening. And now question number 3. So copy this solution, students, carefully, okay? And now next problem is 3rd. Find the maximum value or minimum value of this function. So let us assume f of x is equal to x to the power 1 by x and y equal to, okay. So as this is a variable to the variable, we take a log on both sides. So log y to the base e is equal to 1 by x and log x to the base e here, okay. And now differentiate. Actually we want to differentiate log y, but we differentiate like 1 by y and dy by dx, not very here, right here, and this is so would be so lengthy. So that's why see the writing technique. So you write like that, okay, and this is you can write here u by v. This is the x square. So and also x square and x, and derivative of log x is 1 by x here, and minus and log x to the base e, and derivative of x is 1 here. So 1 minus log x to the base e, and this is divided by x square. Actually, if we derivative 1 by y dy by dx, and then in the case of second order, and 1 by y are transferred to this, and so lengthy, it would be so lengthy. So that's why we can actually we have to find the maximum minimum. So don't need it to differentiate don't need it to write like 1 by y and dy by dx. Actually, you can write like that, okay. So now again differentiate. See, this is actually okay like that, okay. This is as x to the power 4, and this is here unchanged, and derivative of that is here minus 1 by x, and see again 1 minus log x to the base e, and again differentiation of x square, and that is twice x. So see here x to the power 4, or we can write here x cube, and this is here, and this is here minus x. We take a common minus x, and we take a common x only and cancel this, okay. So this is minus 1, and this is here minus 2 and plus 2 log x to the base e here, okay. Am I right? Okay. So see, this is here minus 3 plus 2 ln x by x cube. And for finding a point, and you know the first order derivative would be a 0, and y is 0, you know. So that's why, and from 1, so 1 minus log x to the base e equal to 0. So implies that x is equal to actually e. Now put on the second order. So if we put there minus 3 plus 2 into log e base e here is 1, okay, and this is here e cube. So this is less than 0. So y equal to x to the power 1 by x process maximum. So y equal to x to the power 1 by x as maxi at x is equal to e. Therefore, the minimum value is equal to, so that is e to the power 1 by e here actually, okay? E to the power 1 by e, this is your answer. Okay, that's the process, minimum value of this function. Okay, and now question number 4. Now 4 here about this 7 point after the discussion, and do the problem to your book, okay? And now see, now proceed the question number 4 here, and prove that the greatest rectangle inscribed in a given circle is a square. So first of all, you draw a circle whose center be 0 like that, okay? We draw a circle. We need to draw a circle. Okay? Prove that the greatest rectangle inscribed in a circle, and let us assume this is a rectangle. Okay, let us assume this is be R, and on the surface of the circle we have x, y. So then the equation of the circle, therefore the equation of the circle is here x square plus y square equal to r square, where r is constant. Since the circle is a fixed circle, the is a fixed circle, so then r is a constant. And including the circle means instead a rectangle, so then this length changes, okay? And when it has a maximum area, then it will be a square. Okay, rectangle is a square. Now see, now area of the rectangle, we want to find the area of the rectangle. Let us assume A, and this is their x, and this is their y, and this is their y. So the length of the rectangle we have twice y. Okay, and also twice x here. So that is therefore xy, implies that a square is equal to 4 x square. Sorry, this is not a 4. This is 16, and 16 and y square. Students, see careful. Why you are doing a square? Actually, if we put the value of y, so it will be a root over. So there is some problem for differentiating on the both sides, and now actually we have to proceed this finding the maximum minimum too easily, and so that is the technique, and that's why we follow this technique here, and find here y square, and that is here r square minus x square here, and multiply is there, and 16 r square and x square, and that is 16 x to the power 4. And now again we differentiate a square, but don't write like twice a dA by dt. We write like that, okay, only. And now this is 32 r square into x, and 64 x cube, and 64 x cube. Now find d2 dx2. Now find d2 dx2, and this is equal to 32 r square, and this is a 64 into 3 x square. Okay, now take a 0 of that, and why we are 0, which we have discussed in the previous problem was there, okay, and if we take this is the first term be 0, so and then what happens here, we take a 0 take a common here, and also 32, so there is a r square, and now 64, and that is 32 to the 64, so that's why 2 into x square is here, okay, but x never be 0, so that's why within the bracket it would be a 0. So as x is a length, so x can't be a 0, so this is r square equal to twice x square. Now and see, we get here the value of x here plus minus r by root 2. This is the meaningless, actually x is a length, so you can take a negative sign, and this is the meaning length. So in this maximum or minimum chapter, as we know, x is a breadth and length also. So we have a find here. So this is r by and root 2. This is here. Actually, okay. This is the value of x, and now put on the second order like that as a square. So this is x equal to r by root 2. Okay. So this is equal to 32r square. And now this is here 64 into 3 into x square. X square equal to r square by 2. Okay. This is 32. See, if we differ this, then we get a less than 0. So at x equal to r by 2, we get a maximum. So the area of the rectangle is maximum when x is equal to r by root 2. Okay. So therefore then twice x is equal to, this is 2r by root 2, this is root 2r, and x square plus y square equal to r square. So now find the value of y. So y square, put the value of x here, so r square by 2, and this is r square. So y square is equal to r square by 2, so y equal to r by root 2. Same as twice x is equal to, so that is 2r by, so root 2, that is root 2 into r. See both the same. Therefore, this is here y actually. So twice x is equal to twice y. So length and breadth are equal. So here length and breadth are equal. Therefore, rectangle is a square. Therefore, the is a square when the area be maximum, when the area of the rectangle is maximum. Okay. So this is the logics that you can say then the rectangle be a square. Okay. I think all of you are better understood. Okay. Enjoy this problem, and we have to proceed the second 5 here and see x by x minus 1 and x plus x minus 4 here. So how can we would find the maximum value and minimum value? There's we have some technique we have to use here. Actually partial fraction needed to use here. So see here, actually first order it would be as easy for this type of problem, but second order there's a problem, so that's why this type of problem need to have partial fraction. So see, this is a question number 5, and f of x is equal to that is x by x minus 1 into x minus 4. So now how can we easily find the partial fraction? So see, we have a 1 by x minus 1 and 1 by x minus 4. We can write like that. Okay. See, if we take a LCM, then we get these two part, and x is here this, and on the numerator part what we get here. See, if we take a LCM, then on the numerator part there is a x minus 1 minus x plus 4, so it would be 3. So on the numerator part there was a absent that is 3 here, so we divide by 3, so balancing. So now 1/3 here, now I have a right here, I multiply the x here, so x by x minus 4, and now x by x minus 1, and also we can write here x minus 4 and this is here plus 4 here, and by x minus 4, and also x minus 1 doing plus 1 by x minus 1. So see the technique, this by this here is 1 plus 4 by x minus 4, and this by this 1 minus 1 by x minus 1. Okay, so these 1 are cancelled, so you get here 1 by 3, and this is, we can write like 1 by 4, this is 4 here, and x minus 4 to the power minus 1. So, and this is the easiest technique to find the differentiation. So this is here f of x. Now find f dash x here. So this is here 1 by 3. So minus 4, x minus 4, this is minus 2, minus plus, and this is here x minus 2. See, and this is the easiest derivative. Okay, and so now again doing second order, and that is 1 by 3. So you can take easily minus 2 to the 8 here, and x minus 4, and this is your minus 3, again minus 2, and this is x minus 1 whole to the power minus 3. And see, this first order be 0 here. And now find the value of x is here. So this is the first order, f dash x is 0. So you can rightly written that minus 4 by, and this is here x minus 3. This is the, sorry, x minus 4 here. X minus 4 whole to the power square, okay, and equal to minus, if I take on the right hand side, so this is 1 by x minus 1 whole square. So these are cancelled. So 4 into x minus 1, and this is x minus 4 whole square, and doing square root. So x minus 4, and that is equal to plus minus 2 into x minus 1. Take a positive, therefore x minus 4 equal to twice x minus 2. So doing minus x, and that is equal to 2. Okay, and then 2 here. So implies that x equal to minus 2. And when x minus 4 is equal to minus twice x plus 2. So you get here, this is 3x, and that is here, and 6. So you get here plus 2. Actually, when f dash when x equal to minus 2, then f double dash x is equal to minus 2. And see the second order. So that is here 1/3. And see, this is 8 by, if we put minus 2, that is minus 6 to the power minus 6. So this is here minus, and 6 to the power 3, and this is here 6 to the power 3. Okay, and 6 to the power 3, and this is here minus 2, and 2 by, and this is here minus to minus 3. So this is plus 3 to the power 3. So this is 3, and now here 8 are cancel. So this is 1 by 3 cube. So this is 2 by 3 cube. See, this is more than 0. Therefore, the function has minimum when x is equal to minus 2. Therefore, the minimum value is equal to, this is your function. So that is f dot minus 2. This is minus 2. This is minus 2 minus 1. And here minus 2 minus 1. And simplify this equation. Okay. So see, minus plus. So 2 by 3. And this is 6 here. So 1 by 9. Okay. And see, f double dash equal to 2. So see here, this is here 1/3, we have put here this is 2, so that is 2q minus 2q, this is here doing minus 8 by 2q. Okay, we have put here 2, okay, only 2, 2 minus 4, that is minus 2q. This is 2q minus, okay, if we put here 2, then we get here 1, and this is here minus 2, okay, this is less than 0. So therefore the function has maximum. Therefore the maximum value is equal to f of 2, and put here is 2, this is 2, and 2 by 2 minus 1, this is 1, and also 2 minus 4, this is minus 2, and this is a minus 1. C. Okay, so this is their 5 have done. Now proceed to the 7th first, then we are doing the last is number 6. No, proceed to the 6, yeah, okay, then after 7. Okay, we maintain the order here. Okay, very interesting question. A window is the form of rectangle. A window is the form of rectangle, is inscribed by a semicircular opening. The total perimeter of the window is 10 meter. Find the dimension of the rectangular part of the window to admit the maximum light through the whole opening. Okay, so a window is the form of rectangular is surmounted by a semicircle. So see the drawing here first. This is the rectangular shape and semicircle also. Okay, this is the window. Let us assume this length be x and this length be y. Okay, so y is this. So now perimeter is y, and this is x, and this also x. Let us assume, so there is a twice x here. Now we have to find the perimeter of the semicircle. So now half of the perimeter is the semicircle, and to the circle B here, that is 2 pi r by 2. Okay, 2 pi r by 2. So that is pi r actually, and then y plus twice x. Okay. Now the semicircle of the circle is equal to 2 pi r. R means here x by 2. So then this length is pi x meter. Okay. Therefore the total perimeter is equal to y plus twice x plus y plus y. Okay, and after this length is here pi x, and given that is equal to 10 meter. Okay, it is 10 meter. This is the given cases. And now twice x plus twice y, and this is here pi x, and this is here pi, actually 10 here, so 10 meter. And now find twice y, and this is here 10 minus twice y, and this is here 10 minus take a common 2 x actually, then 2 plus pi here, Okay. Now find area. Actually, find the dimension of the rectangular part of the window admit the maximum light. Let us assume per unit square length C unit light are entered to the from the window. Okay, so how much light are admitted to the from the window or C. First we have to find the area of the rectangle. Now area of the window is equal to, this is pi r square, this is x square by 2. So this is the part here. Okay, and after that this is the length is here y and breadth is here twice x. Okay, so see, so that's why, and that is equal to pi x square by 2. Okay, and now x here and bring twice y, and what is the twice y? Actually need to a single variable, so that's why here is a two variable x and y. We are transferred to in place of y put this. Okay, so this is convert to a single variable. Now multiply this pi x square by 2. Okay, and x square plus 2 plus pi 2 plus pi. Okay. And so let us assume C, but C does not depend on C is a constant. So that's why, and this is our area. Now the maximum, let us assume C whether actually let us assume C is a unit of a light per square unit. Okay, so AC, so doing AC here, so that is a P, total light are admitted to from the window to the house, and that is AP, P equal to AC, and C is a constant. So now C into pi x square by 2, and this is 10x, and x square plus 2 plus pi actually. Okay, so dp by dx here, so this is 2 pi by 2 into x, this is 10 and twice x, and this is 2 plus pi. Okay, again differentiate, we get here pi, and this is by 0, and this is x is 1, so this is 4, and this is here 2 pi, and then we get here minus pi and minus 4, and this is negative. So it shows that the maximum light are admitted. So it shows that the P is maximum actually. So maximum light is admitted here. So P has maximum when actually this be a 0. So this first order be a 0. So that's why we take a 0 here. So C into, not needed to write here C, actually C is a scalar, fake constant. So pi x here only, 2 to cancel, plus 10 here. So again we do have twice x into 2 plus pi. Okay, so see, this part be 0 here. And now doing pi x plus 10, this is 4x. This is here 2 pi x. Okay, and this is 10 here, pi x plus 4 x, therefore x is equal to 10 by pi plus 4. Okay, and now twice x is equal to, actually twice x is the length. Okay, actually twice x is the length of width. Anyway, This is 20 by 5 plus 4. Now you have to find the value of y here. And this is here y. Okay, this is here y. And that is twice y and 10 minus x into 2 plus pi. This is here 10 and x means here 10 by pi plus 4 and 2 plus pi, and take LCM 4 plus pi. Okay, and that is 10 pi plus 40, then 20 and 10 pi. Okay, these 10 pi are cancelled. So 20 by 4 plus pi here, this is twice y. Then y is equal to 10 by 4 plus y. Also, break we are 10 by 4 plus pi. So this is your answer, and this is the dimension. Okay. So length is 20 by twice x is length. See, this is 20 by, this is more than this, so you can assume that this is the length. Okay, and this is the breadth here when the maximal light we are admitted. And now proceed to the last question, and this is a very easy question. And see, and this is a function y equal to 4 into e to the power twice x and 9 into e to the power minus twice x, and now we have to the minimum value of that is 12 actually. So differentiate, so dy dx and 8 e to the power twice x, 18 e to the power minus twice x, again d2y dx to e to the power twice x, e to the power minus twice x, and this be a 0. So 8 into e to the power twice x equal to 18 into e to the power minus twice x. So this is there e to the power 4x. Okay, actually 18 by 8, so 9 by 4. So we got e to the power twice x is equal to plus minus 3 by 2, but e to the power twice x never be minus 3 by 2, so can't be negative. This is an exponential, so we can't be a negative here. So therefore e to the power twice x is equal to, this is 3 by 2. So now second order d2y and dx2 we have to find e to the power twice x at 3 by 2, that is 16 into 3 by 2, and 36 by, this is 2 by 3 here, actually 3 by 2. Okay, so this is more than 0. Okay, and therefore it has a minimum, so therefore the value is equal to, we put here 3 by 2 only, so 4 into 3 by 2, and this is 9 by 3 by 2 here. Okay, and these two are cancelled, that's why this is a 6, and this is 2 by 3 here, so 3, so 6 plus 6 is 12. So this is the minimum value. See, this is your answer. Okay, I think all of you have better understood, and see carefully, and from the book proceed the problem. Next some problem you have to introduce all of you here. Okay, bye everybody.